Here we are charging at 70 amps and 13.7 volts. Checking out our 15 amp circuit breaker. Unfortunately, here we are at 15.5. It hasn't blown, but I am surprised to see that high of amperage. All right, here we are just doing a voltage test. Looks like 114.2 of AC voltage. All right, did a little bit of math here, doing a little bit of application of Ohm's law. If the converter was charging at 13.7 and it was outputting 70.1, should be 960 watts on the DC side of things. Now to see the draw on the AC, or on the AC side of things for the converter, 960 divided by 14.2 is what we measured. Should be theoretical 8.4 amps placed on that converter circuit breaker, but as you saw, we measured 15.2. So the discrepancy between them, I don't know, I suppose it's the inefficiency of the converter, a little bit of heat loss, possibly this cheap Amazon fluke meter, amp meter, is maybe not as accurate. Maybe there's something else I'm missing, but in theory, that's what it should be. But we are doing 15.2, so I think I'm just going to go ahead and swap out that circuit breaker just so we don't have any trouble down the road. But even at maximum capacity, if we had 14.4 volts run at 80 amps, which would probably never happen, but it should be 1152. And 1152 divided by the same 114.2, which I know in most scenarios it should be 115 or it should be 120, depends on your housing circuit, but this is what we measure as 114. Anyways, should be maximum 10 amps, but nonetheless, we were doing, I measured between 14.8 and 15.2. So yeah, we'll just go ahead and switch it out just to avoid any problems. All right, we're gonna change out this circuit breaker. I'm actually gonna add a circuit breaker here, but I'm gonna take this one out for the meantime, take it down to the hardware store and match one up and come back with a 20 amp to fit this hole. That way it will fill this extra hole. All right, there's no power on the system. We'll make sure that you have all the power off before you start touching the stuff. But to take the circuit breaker out, there's a little ledge back here that it sits on. So basically you just rotate it out. You tilt the top this way and then lift it off the edge. So basically just like this, rotate it off and then lift it off the edge. And then to take the wires out, there's 2 set screws right there. We're just going to take this wire out and move it over to the new circuit breaker, which is going to be put over in this side over here. Right, taking out the converter of this 15 amp and just left the other side blank. We'll use it for future if we ever need anything. And we'll slide this back in. So put it back in, just tilt it, set it on that ledge back there. You can see it just hooks there, and then you just push it right on in. Now we got a new 20 amp, $7 is all it costs at Lowe's. We'll plug this in for the converter, and then we won't have to worry about it. All right, wires in, tighten down, and same thing, we'll just set it on that ledge on an angle, push it in, and easy as that, put the cover back on, and put power to it. All right, it's all done. Got the 20 amp in, tested it, it's working, and relabeled everything down here. So we got the converter in this spot. This is where the converter was, so we're just gonna leave that blank now, call it NA. And if we have any future upgrades or anything that needs a AC separate circuit breaker, we've got a spare one now. There you go. I think that'll work out better, and we won't have any issues with that tripping off. I don't know if it would have tripped, but you know, I'd rather, for the price of a $7 circuit breaker, just get it done now and not have to worry about this kind of stuff while we're out camping. Thanks for watching.